Hey y'all, it's Mr. Boyden back at it again. Today we're going to be looking more at circles, and we're specifically going to look at the relationship between the circumference of a circle and its diameter. Okay, so to understand this, I was thinking about this as I was drinking my coffee this morning actually, because I was looking at my cup, and my cup is a cylinder, so it's circular. So I wanted to start out with a little bit of an exploration and a question for you today, and the question is this. On this mug, and it wouldn't work on any mug, but it'll work on this one. On this mug, I want to know what you think is longer. Do you think the circumference, the distance around the outside, is longer, or do you think the height is longer? Okay, so I'm going to show this to you again. There's no camera tricks here. There's no editing tricks. I'm just sitting in my house and showing you a mug that I'm literally drinking out of this morning. Okay, so here it is again. Here's the height. You can see the circumference. I'm going to hold it back so you can get a little bit better perspective on it. Here it is again. Okay, so that's the question. Which one is bigger, or are they the same? And is one a lot bigger than the other, or is it really close? Okay, so that's what I'd like you to think about. Let's look at an exploration of how we would answer that question. It turns out that it's pretty easy to measure a height. You could just use like a tape measure or something like that. But it's not quite as easy to measure a circumference unless something is bendy. So before I started making this video, I took a piece of string and I cut it to the exact length of the circumference. So I want to show you that now. So I'm going to wrap this around, and there it is, and I hope you can see that it meets. Let's come a little closer so you can see. So again, wrap around, nothing at my sleeve. I'm not even wearing a hat. Okay, so there they are, and they touch. And they overlap just a little bit, but I had trouble cutting it exactly. So let's see now how that compares to the height of the cup. So I'm going to hold the cup up. Here's the string, and not even close. Okay, so I want to demonstrate to you, I am holding the string right at the top of the cup, and it goes way down past the bottom. So what's going on here? Okay, well, it turns out that some of us are really good at estimating distances that are not linear, meaning like a distance that has some sort of a curve to it. We're really good at understanding distance if it's measured directly, but for whatever reason, curves don't make as much sense to most of our brains, so we have trouble estimating it. Okay, so what we might want to think about is because remember, the whole point of this video is understanding what's the relationship between the circumference of the circle and its diameter. So I want to show you how you actually could have estimated this a lot more easily and a lot more accurately. And then this is a trick that I would encourage you to try on your family, to try on your friends, get them to guess. If you got it wrong, see if you can get them to get it wrong too. Or if you got it right, try it anyway, okay? So something I want you to see is this relationship between circumference and diameter. So what I'm going to do for that is I want to know this circumference that went around, how many times could it double back on itself and go across the diameter? So to do that, I've got scissors with me here. And so I'm going to lay this across the diameter, and I know it's kind of hard to see, so I'm going to lay it across the diameter. And then I'm going to make a cut. And the reason I'm going to do this is I want to know how many times this piece of string can go across the diameter. So here's my first cut. Maybe. Looks like I got some dull scissors here. Okay, let's check and make sure I did an okay job. So I'm going to show you that that really is the diameter. Okay, let's see how many more of those I can get out of this piece of string. So I'm going to set this down for a minute, and we're going to pull our main string back again. Okay, so there it is. So there's my second piece. Now I want you to notice what happens with this third piece when I lay it on here. So here's my third piece. The third piece goes all the way across, but there's a little bit extra hanging off. It's not even half, it's just a little bit extra. So I'm going to cut that. And then I want to show you what I have. So with all my cuts here, I have 3 diameters. Okay, here they are. 3 diameters. And then I have this extra little piece, and it's not very much compared to the diameter, it's just a little bit. So what is that? Do you know of any numbers that are just a little bit more than 3 that are really relevant and important in math? I hope so. Guys, this is pi, okay? And that's what pi is. Pi, yes, it's a number. Yeah, I get that. But specifically, pi is the relationship between the circumference of a circle and the diameter of a circle. And what pi tells us is that the distance around our circle is 3 and a little bit more, which is what we saw here. It's 3 and a little bit more diameters. Okay, so I think this is kind of a cool trick. The first time it was shown to me, by the way, I got it wrong. I said that the height of the drink, it was a drinking glass in my case, and I said the height would be more, and I lost $5. So be nice, don't take anyone's money, but this is a cool trick you can use to educate some of your family and friends. Now that we have a basic understanding of what pi is, let's sum up those key ideas for the notes. Okay, so what we had said is that the circumference is, or we remember we cut that diameter. The diameter went around a little bit more times. So one way of it describing circumference is it's pi times diameter, and that's shown by those 3 strips and a little bit extra that was left over. Okay, so remember that diameter is here, circumference is all the way around the outside. Okay, and then another way of expressing this exact same thing, we could say that it's the circumference, but pi multiplied not by diameter, we could instead use radius. Now remember that there are 2 radii to make one diameter that go all the way across, so we're going to express that here. So 2r. Usually how that's written, though, is 2 times pi times the radius of the circle. Let's look at an example. All right, circular fountain has a radius of 5 feet. I would encourage you to draw this with me as you go so that you can understand what we're talking about. So circular, that's my best attempt at a circular fountain with a radius of 5 feet. If the radius is doubled, how does the circumference change? How does the area change? And how does the circumference to diameter ratio change? All right, let's run through all these. So what we have to imagine is 2 circles, one with a radius of 5 feet. They said if the radius is doubled, so let's color code that something different. Let's do green. So if the radius is doubled, so if the radius is 10 feet, we're going to look at how the circumference changes. So let's remember, circumference is the same as 2 times pi times radius. So that should be a pretty easy calculation for both of these. So for this one, that would mean the circumference is 2 times pi times the radius, which is 5. And the way we simplify this is it's sort of combining like terms. So 2 times 5 is 10. So 10 pi feet. And yeah, you can type that in the calculator if you want to. What about for the larger circle? The circumference is still 2 times pi times r. It's just that this time r is 10 feet. And so 2 times 10 is 20. So 20 pi. So let's answer this question. If the radius is doubled, how does the circumference of the fountain change? The circumference is also doubled. It's twice as big. Because 20 pi is twice as big as 10 pi. And you know what? I should annotate this as feet. What about area? That's something that we haven't talked about yet in this video. So let's make that note here. The area of a circle is given by the equation pi times radius squared. So let's go explore that down here. What would the area look like? Area is just pi times the radius, that's 5, times 5 squared. So 5 squared is 25, so this is 25 pi square feet, or some people say feet squared. How would it be different? So we have to answer that question. How does the area change if we double the radius? So let's do the same calculation over here for the green. So the area is pi times radius squared, so pi times 10 squared. And that would be 100 pi square feet. So what's the relationship between those two? 25 pi and 100 pi. Well, 100 is 4 times as big as 25. So here the circumference doubled. The area is 4 times bigger. Now why is that? I'm going to show that over here on the side. Let's consider that equation area equals pi times radius squared. If you double the radius, what happens to that equation is that we have area equals pi times a doubled radius getting squared. Let's remember what that means. That would be pi times, and remember squared means times itself, so pi times 2r times 2r. So what would happen is we'd combine these 2's together and we'd combine these r's together. 2 times 2 is 4, so we would get 4 pi r squared. Now remember, pi r squared, That's the original equation. So what this is saying is when you double the radius, you get an area which is 4 times larger, because that doubling factor gets squared. How does the circumference to diameter ratio change? Recall, that's what we did in the very beginning of this video. We explored how does the circumference relate to the diameter of a circle. And one of the things that's cool about that is it never changes. It doesn't matter what circle it is, doesn't matter how big, doesn't matter how small. That relationship is always the same. That relationship is always pi. So how does the ratio change? It doesn't. And what's the reason? Because pi, and guys, that actually explains it. Pi is the relationship between circumference and diameter, stating that circumference is about 3 and change diameters. Let's look at another example. This would be a great time for you to pause the video and give this example a try on your own. If a circle is inscribed in a square with a side length of 10 centimeters, what is the circumference of the circle? Let's give it a try. I'm going to do my best to draw this out. So there's a square, and there's a circle inside the square. So the center of the circle is there, and this is going to be kind of tough for me to draw, but there's a circle in here. And the square has side lengths of 10 and 10, and it's centimeters. We are asked what is the circumference of the circle. So I'm going to take together all the knowledge that I have so far from this video. They asked about circumference, and we learned that circumference is pi times diameter. It's also the same thing as 2 times pi times the radius. So if I knew either the diameter or the radius, that would be enough information to answer this question. Well, do you know those? I think we do. I'm going to draw in the diameter. Can you see how long that is? You should be able to see it's the same as this side length of the square. It's 10. What about the radius? So if that's 10, how long is a radius? Well, a radius is always half as much. So regardless of which part of this formula we use, we're going to get the same answer. I'm going to show that now. Okay, so that'd be pi times the diameter is 10, or 2 times pi times the radius. 2 times 5 is 10. There's 10. So 10 pi, and it is centimeters. Now, if you have a calculator that has a pi button, you can type that in. If you don't, you can always use 3.14 if you wanted to approximate it. There's no need to approximate it on this one. I will, just to show that we can, and so you can check your answer if you want to. So I go 10 times the pi button on my calculator, and it rounds out to 0.42 centimeters. Let's look at another example. The circumference of a circular hot tub is 24 feet. What is the radius of the hot tub? I'm going to go back to the main concept of the lesson again, that the circumference is 2 times pi times the radius. And what we're going to do is we're just going to substitute in the values that we know. So right now, what do I know? The circumference is 24. So 24 feet equals 2 times pi times the radius. I don't know the radius yet. Now, one thing I want to make really clear here, guys, pi is a number. Okay, it rounds out to 3.14. It's not a variable. Some people get a little stressed out by the symbol. There's no need for that. R, that's a variable, although we're about to solve for it. And then we'll know what number it is in this equation. Okay, so here we go. What I'm going to do, since 2 and pi are both numbers and we have multiplication here, I'm going to use division to cancel that out because it's the opposite of multiplication. So divide by 2 pi, and since this is a real world problem, it's best to turn this into a decimal answer or to type it in the calculator, and if we need to round it, that's just fine. So I'm going to go 24 divided by 2 pi, and I get 3.82 feet. So I think I'm just going to round that to 3.8. All right, so the radius is 3.8 feet. And that's it. Let's do another one. All right, here it is. If we estimate the diameter of Earth is 8,000 miles, which is really close actually, find the average speed in miles per hour Phileas Fogg must travel to circumnavigate the Earth about the equator in 80 days. Wow, there's a lot going on here. Okay, first of all, let's get our vocab down. Circumnavigate, That means to go all the way around, like to navigate your way around the circle. They say it's the equator, so we'll know that it actually is the circumference with a diameter of 8,000 miles. So we're kind of looking down on top of the Earth right here from maybe one of the poles, okay? And we're told the diameter is 8,000 miles. We need the average speed in miles per hour in 80 days. So when they say miles per hour, what that means is we need to know the number of miles and we need to divide that by the number of hours. And if we had those two numbers, then that would be fine. So he's going to go all the way around the equator in 80 days. That's going to turn into miles. That's a circumference. So circumference equals pi times diameter, or 2 pi r. Both of them work here. So I'm going to use pi times diameter. That's 8,000 pi miles. So I know the circumference. So actually, I can plug that in right now. 8,000 pi miles. I need to know the number of hours. They said 80 days. Remember that 80 days, remember that 1 day, rather, is 24 hours. So we're going to do 80 days times 24 hours. And how many hours are there in 80 days then? 24 times 80, that's 1,920 hours. So I'm going to bring that in here, 1,920 hours. All right, and this is just going to be calculator time. So I'm going to go 8,000 times pi, and we're going to divide that by 1,920. And that would be 13 miles per hour. And yeah, we're going to round to the nearest whole on this, I think. So that's saying if you were gonna go, maybe this guy's going in a hot air balloon or something. If you went 13 miles an hour, wow, it would take 80 days to go around the Earth. That's a long time. All right, now for our final question today. Why do we use a symbol for pi rather than using the decimal? Okay, there's a couple reasons. As many of you probably already know, the decimal goes on forever. Okay, so it goes like 3.1415926. In fact, there's whole competitions for people seeing how many digits they can memorize. There are people that have memorized out 1,000 digits or more. So one reason we use pi is because that is the exact value. If I say 3.14, that's a rounded value. In math, being exact is really, really nice. Rather than writing 3.14159, that's a whole bunch of symbols, we get a chance to write just one symbol. So actually it's easier and less overwhelming in that way. Okay, so those are just a few reasons why we like to use the symbol pi. Also, it's an easy stand-in that reminds us also that it's not just a number, it's also representing a concept. It's representing that relationship between the circumference and a diameter of a circle. So, hope this video was helpful. I hope you enjoyed it. That's going to be all for today, so we'll see you next time.